As promised in my previous static routing video, I'm going to have a series of dynamic routing videos for Homelabers. This is the first one. It is about RIP. First, let's see what is RIP. This is the Wikipedia page for Routing Information Protocol, or RIP. In fact, it's very old routing protocol. Here it mentioned several very important numbers, and they are also the weakness of RIP. For example, the maximum hops is 15. So apparently it's not good for a big network. Here it mentioned every 30 seconds it will broadcast the update, at least for version 1. It will cause some network problem and it's slow when it comes to converging time. It's not really recommended nowadays. If you scroll down, it mentioned 2 version information. In fact, modern routers, if they are still supporting RIP, normally by default they work in the version 2 mode. You may ask why you are talking about such an old protocol which is not widely used already. The reason is it's one of the oldest dynamic routing protocol. Just to pay some respect and because it's very simple, I'm going to use it as my first topic for dynamic routing. This is the diagram for this video. In the end, we are going to configure all the routings among these 4 different routers. Our goal is to connect this left end red IP address with the right end, the other red IP address. As you know, after you connect the Ethernet cables to individual routers, yes, just within the router itself, it can route traffic among all the links. But if you do not do anything extra, this router will not know the router information of this router. You cannot ping this right side IP address from the left side IP address. That's what routing information protocol for. Let's see how RIP can help all the different routers to share the routing information to make the routing possible. I'm going to use 4 routers from 3 different vendors. Mikrotik Routers have very good support for RIP. Everything is out of box working. For pfSense, it's not officially supported, but not a big deal. We can try to make it work. For UniFi USG or USG Pro, it's kind of in the gray area. It's somehow supported, but it's not completely supported. We will talk about that. You may ask, if it's not really officially supported, why bother? In my opinion, isn't it interesting for us, for Homelabers, to troubleshoot something which are not really supported by the vendors, but if we make it work, isn't that fun? Okay, we will start with the Mikrotik configuration because they are responsible for the left end and the right end. This complete diagram is a little bit messy, so when we talk about each scenario, let's just focus on the routers used. As you can see, there's only one direct connection between these 2 Mikrotik routers, and I noted the ports or interface names we are going to use in this step. For this green link, for each end, it has a different IP address, but they are in the same subnet. For the left side red IP address, it's in another subnet, and in the right side, this red IP address is in a different subnet. So in total, for this step, we are already talking about 3 different subnets. Let's get started. On the screen, you see 5 different windows. In the lower part of the screen, you see 2 terminal windows. They are for these 2 Mikrotik routers. I already SSH into them. Here you see 2 web interfaces. They are for these 2 routers as well. Theoretically, I can do the same configuration in either command line interface or the web UI. I prefer to use the CLI to do configuration, but sometimes I will show some information using web UI just for convenience. From the web UI, you can also see I'm running RouterOS version 7. Let's configure the first part for Ether 1. What we are going to do is just add a new IP address for this interface. Pretty straightforward. Hit enter. As you can see in the web UI, you immediately see the newly added IP address. By the way, there are two pre-existing ones. They are there for other purposes. They have nothing to do with this video, so you can simply ignore them. In the same way, we add Ether3. It's refreshed immediately. We are good with the left side IP addresses. Move on to the right side, add the other two. Just by looking at the port names, you can see the left side router is a normal RJ45 based, and the right side, they are all SFP plus ports, so that's why the port name is so different. I'm adding IP address for the port 3, port 4. Okay, we are good about the IP addresses. In the left side, let me run this command, IP route print. This is the current routing table for the left side router. Ignore the first one, the second one, and the third one. These two are related to what we just added. The router knows the 110 subnet and the 150 subnet, but there's no way the left side router knows the 140 subnet. Then let's move on to the right side, run the same command. Similarly, it knows 140 subnet and 150 subnet, but it doesn't know 110 subnet. If we try to ping from the left side to the right side, the ping won't be successful. Let's run this ping command. See here, I indicated the source IP address, which is this red one, just to make sure the system is using this IP address from this port to do the ping. And as expected, it's timeout. The ping is not successful. The reason is very apparent because the routing table simply doesn't have anything about this subnet. Let's see how RIP can resolve it. To configure RIP, we need to first create a RIP instance. In the instance, we need to define two different things. First, what type of routes we want to redistribute. Here, I'm saying connected and static. Connected means, let's use the left side router as example. The connected means 110 subnet and 150 subnet. To the right side router, the connected means 150 subnet and 140 subnet. So that's redistribute mean. I also can define whether I want to redistribute the default route. I'm saying no. You give it whatever name you want. Let me create it. We have an instance. The next thing is to tell RIP which interface we want to use to multicast the routing information. Even though here you see two links, because these two routers are only connected with the green link, I will only want to redistribute the router information on the Ether3 and on this SFP plus 4 ports. So there's no sense to broadcast something in this Ether1 and SFP plus 3. We don't directly give that information in Mikrotik customizing. We define something called RIP interface template. I'm going to add a new interface template, which is for the Ether3 port, and I'm using the instance we just created in the previous command. In previous version of RouterOS, it has different ways and is more similar to the other vendors' routers, but for RouterOS 7, Mikrotik changed the way for RIP configuration. Now it's very simple. Let me move on to the right side router. So simply we create a instance, and with the same setting, we want to create a template for this port. I indicated the interface name and the instance. Okay, we are done about the right side as well. To validate our settings are effective, let's see on what interface Mikrotik router is using to do the multicasting for RIP information. The way to check it is to run a command. Previously, we create interface template, but now we are checking which interface RIP is using. See, it's using the Ether3 with this special address string, which is this one. Let's check the right side router. Yeah, it's using the SFP+4 port, which is this one. Perfect. That's exactly what we want. Now let's check the final result, the routing table. In the left side router, let me run this command to print the current routing table. See the first column for flags. Letter R means RIP. So you see 3 entries with R. Ignore the first 2 and see the very last one. That's exactly what we want through this RIP configuration. See the 140 destination address and the gateway is 152. This right side router and 140 is the target IP address. Perfect. And in the right side, if I run the same command, you can see similar situation. The very last RIP entry is about the left side subnet. Perfect. To validate whether we can really ping it, let me run the command one more time. Remember previously it failed before we configured RIP. Okay, I ping from the 110 subnet to the 140 subnet. Everything works fine. For this scenario, we are done. The second scenario is about pfSense. As you can see, we have a pfSense in the middle of these two Mikrotik routers. pfSense has direct links to each of them, but these two Mikrotik routers, they don't have direct connection. Let's see how we can configure RIP in pfSense. This pfSense has the 2.5 version installed. If you go to the services menu, you won't find RIP. In previous version, it was there, but it was removed. And if you check the system package manager, you won't find anything about the RIP or route D, so it's completely removed. It does come with a package called FRR. That's a very popular dynamic routing daemon sets in the Linux or FreeBSD world. But if you check the description, it has BGP, OSPF, but it doesn't mention anything about RIP. I already have it installed. If I go to services, I can find many FRR related menu items, but there's no RIP. If you do some research, FRR itself does support RIP. It's just one pfSense added to the UI, to the package. It doesn't implement the RIP part. It's not the end of the world. It's just a challenge. Let's see how we can make it work. On the screen, you see several windows. The lower one, the left side is for the web UI of pfSense. The right side is the SSH session into the pfSense. And in the right side, you see two smaller terminal windows. They are for the two Mikrotik routers. You may ask why when we configure this scenario, we still need Mikrotik. See here, this Ether2 port and this SFP+2 port, they are not the same as in the previous scenario. They are directly connected with the pfSense, so we need to do similar configurations in the Mikrotik boxes as well. Let's get started. In this diagram, as you can see, for pfSense, we have two dedicated interfaces for the two links. Let's configure them. The way to do that is just normal pfSense interface configuration. Let's go to interfaces assignments, and here I choose IGB2 and I say add, okay, and then add IGB3, okay. They were added, but they have the weird name and they still need to be configured with IP address. Let me do that. Start with the first one, IGB2. So I say enable and give it a name. Let's say RIP1. For the IPv4, I say static IPv4. And then for IP address, I give it this IP address. And here I say 24. We are done with the first interface configuration. Apply changes. Okay. Then go to the next one, enable interfaces, give it a name, let's say RIP2, static IPv4, the IP address showing here, okay, 24. Save, apply. Okay, we added these two parts. Then let's move on to the Mikrotik. The way to configure it is exactly the same way as in previous session. So I will speed it up. I will simply paste the command. First, add the Ether2 IP address for the first router. I will add the 120.2 IP address, and the interface is Ether2. Here I will create RIP interface template. Interface is Ether2. Instance is the one we created in previous scenario. Then move on to the right side Mikrotik. Add a IP address 130.2. Interface is SFP+2. Then add a new RIP interface template. Okay, then for these two Mikrotik routers, we do not need to add the Ether1 and the SFP+3 because we already done that in the previous scenario. We are good with these two Mikrotik. Now let's move back to pfSense. There's no UI for RIP setting up, but FRR package does include everything we need. First thing is the daemon. RIP daemon name is RIPD, and to run it, you give it a parameter -d. Okay, it's running. To configure it, FRR provide a interactive CLI tool, and it's for all the dynamic routing protocols supported by FRR, not just for RIP. The command name is called VTYSH. It's a shell. To go to the configuration mode, I will run configure terminal. We want to configure router, and we want to configure RIP. We have two interfaces ready to announce or multicast the routing information, right? So we need to tell the RIPD the same information here. So I will say network 192.168.120.1, then 24. Similarly, for the second part, it's 130 subnet. Let's go to pfSense. In the status, we do have a FRR status. Even though RIP is not supported here, we can check the routing table. We can see whether our RIP configuration is effective. Here in the FRR status, we can see the routing table which is controlled by FRR. It is not the same routing table as in pfSense. It's before FRR communicated with pfSense. We can check our RIP status here. Currently, you can see it only has K and C. It doesn't have R. R means RIP. But we already added the two networks, right? Why Mikrotik hasn't sent the routing information to pfSense? That's because we just added the two interfaces. We need to add firewall rules to allow the traffic. That's what we still need to do. Go to firewall rules, choose the newly created interface. See, no rules are currently defined, so we need to add one. Add a very simple any-to-any pass rule. Change the protocol to any, save, apply, move on to RIP2, add a new one, allow any-to-any, apply. Let's check the FRR status one more time. Okay, now you see multiple R entries. For example, the 110, it comes from the left side router. So apparently the redistribution of the routing information takes time. After I refresh the status again, now I see the 140 entry. Let's go to the first terminal window for Mikrotik, IP route print. Currently for 140 network, you still need to go from the gateway of 150. That's the one we created in the first scenario. I believe the reason it's not showing the 130 gateway is because we are talking about the RIP. The previous direct link has just one hop, but for this route, you need two hops. Let's do a testing. Let me disable the previously created interface, which is directly connected to the right side router. Let me disable that one. Then let's check routing table again. I will run this command: interface Ethernet disable Ether3. Why Ether3? Let's check the previous diagram again. This is the previous one. In the left side, we use Ether3, right? That it is directly connected to the right side. That's why in the routing table is only showing 150 as a gateway to go to 140 subnet. If we disable Ether3, let's check the routing table again. Disabled. Give it some time. Let me run the routing table command again. It doesn't show any R entries yet because by default the RIP will redistribute the routing information every 30 seconds. Give it some time. We will check again. After a refresh, I see several R entries. Let's go back to the current scenario slide. In the new routing table, we see 2 R entries here. To reach 140 subnet, we need to go to the gateway 120. Where the 120 come from is here. It's controlled by pfSense. Once we disable the previous direct link, the RIP dynamically decided what's the current shortest route, the 2-hop route, which is the only route we have now. Previously, before disabling Ether3, we had 2 routes, and the RIP chose the previous one, the shortest one. Now it's choosing this one. So you already see the effect of dynamic routing. Based on the network topology change, the RIP is smart enough to decide what's the shortest route. If I do a ping from the left side to the right side, it should be successful from 110 to 140. Let me write. It's successful. Before finishing this scenario, let's talk about how to make your configuration permanent. Because we just did the interactive configurations. We manually run ripd, and we manually use the shell to configure several network, then it works, right? But if you reboot your pfSense the next time, all your configurations will be lost. How you can persist the configurations? There are 2 ways. You can write a ripd configuration file, like this simple example. See, this command are the exact ones we interactively typed in the shell, right? Now you write them into the configuration file, and then every time when pfSense reboot, you configure the system to run the daemon like this way, ripd, and you say -f and with your configuration file name. In this way, your configuration will be automatically loaded during the system boot. Another way is you write the same commands in the FRR raw configurations. You can check the raw configuration functionality here. You go to services and you say FRR global. You see a tab for raw config. Simple blank input box. You simply paste the command here, and then the next time FRR package will load these configurations. But you need to make sure the ripd is running during boot. That's how you want to persist your configurations. Okay, we are done with the second scenario. Let's move on to the last one, which is for UniFi routers. For UniFi router, we are going to use a similar topology. If you compare to the pfSense scenario, I'm going to use a UniFi USG Pro. You may ask, why not UDM-Pro? Unfortunately, UDM-Pro doesn't support dynamic routing protocols. It's due to historical reasons. USG products were inherited from the Edge router. They share the same OS, so they have the dynamic routing functions as well. But UDM-Pro is based on a new OS, and Ubiquiti hasn't added dynamic routing supports yet. For USG Pro, it has 2 LAN ports, LAN 1 and LAN 2. We are going to use them to configure 2 different subnets and then connect to the 2 Mikrotik routers. First, we need to go to UniFi controller to set up these 2 networks. I already set up LAN and LAN 2. So by default, LAN is already there, but we are going to use this IP address. So we need to change it. I already gave it the 160 network address, and the DHCP server is not relevant in this demo. That's the only thing I changed. I changed the IP address for LAN 1. Go to LAN 2. This is the one I created. It was not there when the system was initially set up. Similarly, it's a corporate network, and here you need to choose the LAN 2 as the network group, and the port of course is LAN 2. I'm not using VLAN. For IP address it's 170, and I simply don't have DHCP server here. Very simple LAN and LAN 2 network setup. You may also know the firewall in UniFi controllers work differently than pfSense. By default, after you add networks, the rules will enable the traffic by default, so we don't need to change anything in firewall. Now we are ready to configure the RIP. In the beginning of the video, I already mentioned RIP is partially supported in the USG Pro because on UI you don't have it, but you do have it in the command line interface. I'm in the SSH session into the USG already. To start the configuration, we need to run configure. This is the command to enable the LAN 1 network for RIP. So I simply say set protocols RIP network and then give it the subnet, which is 160. Very simple. I already run it in the past. Then the next one is for 170, the LAN 2 network. Yeah, it's already added. We are done. As you can see, compared with the Mikrotik or pfSense settings, the UniFi setting is super clean, super easy. Let's validate the setting. Let's show the current routing table in the UniFi router. Show IP route. As you can see, if we do have RIP routes, it will have R in the beginning, but we do not see any R here. Why? Because we haven't done the corresponding settings in the two Mikrotik routers yet. Here we have a new interface to enable. In the right side, we have another one. In the left side Mikrotik terminal, I'm going to run the command to add a new interface, Ether4, with this IP address. Then add a RIP interface template, new interface for Ether4, and using the previously created instance. We are good with the left side router. Proceed with the right side. Add a new IP address for SFP+5 interface with this 172 IP address. Then add a new interface template for this SFP+5 interface for this instance 1. We are good with both the left and the right side Mikrotik routers. Let's go back to USG Pro. Let's check what's the current routing table. It's refreshed. We see multiple R entries for 110 network. Yes, we have an entry. Gateway is 162. This one. For the 140 subnet, let's see. Do we have a 140? Not yet because of the delay. Remember, RIP has a shortcoming, which is the converging time, right? So let's refresh again. Okay, now we see the 140. And the gateway is 170.2, which is this part. Perfect. So we have both the 110 and 140 network reachable already. We are done about this UniFi router configuration. I won't waste your time testing the ping command. It should work. And now let's talk about how to persist the configuration. Let's go back to the original screen of SSH session. See, this is the initial screen. When you log on to UniFi router, see the OS is Edge OS, and it has a warning here. Everything you do here inside this configuration window, it won't be saved. That means it's not really officially supported by Ubiquiti. You should have done everything within UniFi controller, the web UI, right? But for some features, it's simply not available on the UI. You do have the workaround. Yes, you do setting here. Then you save your configuration in a JSON file. Then from controller, you provision the JSON file to your USG Pro. Your configuration will be loaded automatically. On internet, there are many discussions about how to do that. I believe Ubiquiti even has a help document for that. Once you follow that, your RIP configuration can be loaded next time when you reboot your UniFi USG Pro. Okay, this is the end of this video. We configured the 3 different scenarios using the 2 Mikrotik routers and 1 pfSense and 1 UniFi router. And we also tested if we change the network topology, how RIP can react automatically so that the left and right side networks, they can still communicate with each other. That's what dynamic routing is for, right? I'm going to have other videos for other dynamic routing protocols. Thanks for watching.